Let us see how we can solve 6b using method 3, that is the binomial theorem, to expand this question in 6b. Before I copy the question, there is a formula for binomial theorem. There are actually two, but one of them applies to any given number that we need to expand, any expression. But one of them is limited in that you need to manipulate the given question. So I will use the one which is universal and solves every expansion that we can be given. That is, if you have a plus b to power n, some books they say x plus y to power n. A and b are variables, just like x and y. So if you have a number, an index number in this format with two or more terms, like in this case a plus b, binomial theorem says that the expansion of this becomes a to power n. Okay, that means here b is to power 0, and the first term is over 0 factorial. And then how do we get the second term? So we say plus. Now the second term, we drop the power of a, which is n. Drop it here. So we shall have n and then a. We have dropped the power of a. Now the new power of a becomes n minus 1. And then we write b. The new power of b is 0 plus 1, which is 1. I may not show it. 0 plus 1 is 1. And then we divide the second term by 1 factorial. And then we go to the third term. For the third term, again, we drop the power of a, which is n minus 1. So if you drop n minus 1, it finds a coefficient n here. So we multiply them. So we shall have n, which was already there, times the new power of a that we are dropping, which is n minus 1. We multiply them in that manner. Now the new power of a in third term becomes n minus 2. Like if you have n minus 1, then you subtract 1 again from it, it gives us n minus 2. That's why here we shall have n minus 2. And then the powers of b will again increase by 1. So 1 plus 1 is 2. So this term now is out of 2 factorial. What have you noticed? The factorial number on the denominator is basically a power of b. So b to power 0 divided by 0 factorial. If b has a power 1, by 1 factorial. B has a power of 2, by 2 factorial. That is a simple logic for you to remember the denominators in terms of factorial. Plus, remember this continuous depending on n. So it continues until time is reached when the power of a is 0. As you can see here, the powers of a are falling. So it reaches a point when a has a power of 0 and b has a power that has reached n. The powers of b have increased to n. You have a knowledge on that. And then from here we divide by the power of b still, which is n. So divide by n factorial. N is the power given. If it is 1, we stop here. If it is 2, we stop here. If it is 3, we look for the next term, as in our question there. So this is the formula for binomial theorem or binomial expansion. Therefore, if we look at our number there, we need to compare our number to this given expression. So on comparing, let me try to save time, but I believe you're understanding it. On comparing, we see a corresponds to 2x a is 2x, b is 1, and n is 3. So we simply need to substitute for a, b, and c in the given expression of the formula of Pascal's triangle. Thus 2x plus 1 power 3 equals to, you press these factorials on the calculator. 0 factorial. For you to get the factorial depends on the calculator, but you press shift and a button on your calculator which has x factorial. So you press shift, then you press this button, it will give you factorial. So b to power 0 is 1, so we can neglect that, it makes no difference. 0 factorial is 1, so a number divided by 1 is that number. So basically we shall have a, which is 2x, to power n. What is n? N is 3. b to power 0, b is 1 to power 0 is 1, it makes no difference. Sorry for that. And denominator is going to be 1, 0 factorial, so it makes no difference there. Plus, what is our n? Our n is 3. What is our a? 2x. Power n minus 1, n is 3. 3 minus 1 is 2. Then, what is b? b is 1 to power 1. Divide by 1 factorial. If you press your calculator, 1 factorial is 1. So if you divide this number by 1, it makes no difference. So we just leave it. Or it is that number exactly. Plus, what is our n? Our n is 3 into, what is n minus 1? N is 3. What is 3 minus 1 is 2. So there we get 2. I may not show it for the interest of time. But you have heard that n minus 1 means 3 minus 1 gives us 2. A, what is our a? Our a is 2x. I'm putting it in a bracket because there are 2 terms. And even if it is 1 term, putting it in the bracket makes it better for you to avoid errors in terms of sign. Power n minus 2. What is our n? Our n is 3. 3 minus 2 is 1. And then b is 1, but b to power 2 here. Divide by 2 factorial. You press the calculator. 2 factorial, I'm getting 2. So I now divide this by 2. All these were out of 1, which make no difference. And then plus now the third term. Third term again, third term will be, it will be n, which is 3, into n minus 1, which is 2, into n minus 2. Yeah, into n minus 2, which is 3 minus 2 gives us 1 here. And then we put our 2x, which is a. Now the power goes to 0 because it becomes n minus 3. N minus 2 here, the next time is n minus 3. The next time is n minus 4. So 3 minus 3 is 0. And then we have our b, which is 1. To which power? B now is to power 3. To power 3. Then now here we divide by 3 factorial. What is 3 factorial? 3 factorial is 6. So we divide by 6. And then from here we simplify. From here now it is just a matter of simplifying. There's no more binomial. What is 2x power 3? It gives us 8x cubed. What is 2x squared? 4x squared. 4x squared times 3 gives us 12x squared. What is 2 times 3 times 2? It gives us 2 times 3, 6, 12. 12 divided by 2, it gives us 6. So here we shall have 6x. 1 to power 2 makes no difference. Plus, again 2 times 3 times 1. 3 times 2 times 1. This is to power 0. This one here is to power 0. So it means here we shall have 2 times 3 This one is power 0, so this one gives us 1. So here we have nothing. So 2 times 3 is 6. Yes. 6 divided by 6, it is 1. Because here this is 1, this is 1. 1 times 1 is 1, times 1 is 1, times 2 is 2, times 3 is 6. 6 divided by 6 is 1. And this is the final answer. And if you go back and you look at the other methods that we did, the first two methods, you'll find that the answer is the same. So this is the answer using the binomial theorem. I did all the three methods simply because if the question is specific that use binomial theorem to expand this, then you can be in position to do it and you get your answer appropriately. This concept needs a lot of practice because I'm sure somewhere here in getting our last term, you might have been a little confused because I've not written the expression here. But for you to understand better and have a deeper background and foundation on binomial expansion, I encourage you to go to our Senior 3 playlist on binomial theorem and you learn from there. This is Vision Plus, and we appreciate you for being here.